Good morning, ladies and gentlemen. So, another math lesson about systems of linear equations. This time we're going to solve systems of linear equations using subtraction. Full disclosure, it's the same as using addition. You're looking for one tiny thing, but it can be changed in any case. And if you remember from the last video, I used that word elimination. So our goal here is to eliminate one variable, and by efficiently, I mean as easy as possible with accuracy. Okay, so the big idea here is when the coefficients of like terms are the same, so we want exact matches. The addition method is efficient. It's also efficient when the coefficients could quickly be made to be the same. And if you remember from the last video, there was one where I multiplied everything by -1, turned one whole equation the opposite, and boom, we had a match. We can do that same thing now. So in this first example, if you notice, 2y matches, okay? 2y in both equations. So here's what we mean by subtraction. It's almost crazy simple. I'm going to write the top equation, 3x plus 2y equals 10. And then I'm going to subtract. But instead of just a subtraction sign and the line like we did with numbers in elementary school, we're going to turn everything here negative. We're not negative, we're going to make it opposite. So instead of x, we have negative x. Instead of 2y, we have negative 2y. And instead of -8, we have a positive 8. So this entire thing turns into the opposite, okay? And then we do the same thing we did for addition. That's why these are so interrelated. Most textbooks actually teach them together as elimination, okay? So if I had 3 Oreos and I subtract an Oreo, 2 Oreos, so there's 2x. These cancel each other out, equals 18. Okay, so all you did is take this bottom equation, or the simpler of the two, turn everything to the opposite. You're subtracting by making everything the negative of what it was. Okay, so then with 2x equals 18, divide both by 2, x equals 9. Now, once I know that x equals 9, I could put it up into an equation. And it doesn't matter which one I use. You could pick either one. You'd get the same awesome solution. Okay. So instead of x, now I have 9. That's where that 9 came from. I'm going to subtract 9 on both sides. 2y equals -17. Divide by 2. Divide by 2. Y equals -17 over 2. Now, a couple ways we could write this. Okay. So our solution could be 9 -17 over 2. Or it could be 9 -8.5, if I wanted to use mixed numbers. Or it could be 9 -0.5. Just pay attention to the directions if it asks you to have everything in a decimal form or in a mixed number form. We all know that Savas doesn't like improper fractions. So it would be one of these two, but all are good for different things. Okay? So all of these are the same values, just different formats. Pay attention to the format when you're doing the answer part of math lessons. Now let's take a look at another one. Okay. On this one, I'm going to zoom in a little bit just because of the way I have things set on my desk right now. Okay. We're going to notice that we have two negative y's. Negative y and negative y. They match. Okay. So once again, I'm going to take this bottom one and I'm going to subtract it. It's a complete use of air quotes because it's really what it is. Turn everything opposite and use that to eliminate. So the top one I'm leaving the same. I chose that because the numbers are larger. And if I'm going to turn a bunch of things negative, I wanted to go with the smaller values. That's the only reason. So now instead of 2x, I have negative 2x. Now instead of negative y, I have positive y. And now instead of 1, I have negative 1. Now I'm just going to combine like terms to eliminate. 3x minus 2x is x. Negative y and y cancel out. 4 and negative 1 are 3. So x equals 3. That's it. And now I take that value, I substitute it in to one of the original equations, nothing modified. And instead of x, I can now use the value of 3 because x equals 3 minus y equals 4. 9 minus y equals 4. Now, most of us already know what y is in our head, but let's prove it. Subtract 9 on both sides. Y equals negative 5. I'm sorry, negative y equals negative 5. That happens to so many of us. Well, if negative y equals negative 5, then y equals 5. And then we write our solution, 3, 5. Now, once again, we will practice more of these, okay? When the things match so well as they do in these two problems, okay, this is such a good method. And then if they don't match, you still have substitution as a method that you know how to do that will work for other things. Okay, so can't wait to see you again. Please give your best effort to your try problems, and I'll see